Alright, so yesterday we were factoring polynomials or trinomials or even differences of squares, but today we're going to factor out the GCF or the greatest common factor, and we're also going to factor by grouping, and I'll show you what that means in just a second. Okay, so go ahead and read through this. You might want to hit pause. Alright, so in these problems we are going to factor out the GCF or the greatest common factor. So what you want to do, look at number 1, we're going to ask ourselves what is the biggest number that can go into 20 and 35, and the biggest number is 5. So now take a look at your x's. I can pull 2 x's out of that one, but I can only pull 1 x out of that. So you have to take the smallest number of your variable. So I can only pull out 1 x because I can't pull 2 x's out of that x right there. Alright? So 5x is our GCF. So now we want to ask ourselves what times 5x would give us 20x squared, and that is 4x. What times 5x would give you a positive 35x, and that is a positive 7. Now you might want to just go ahead and distribute just to check your work and make sure that you come up with the original answer or the original problem. Otherwise, this right here is factored. Alright, so now let's take a look at number 2. So ask yourself what the biggest number is that you can pull out of 14 and 21, and that is 7. And so look, I have 3 p's here, but I only have 2 of them here. So the most I can pull out is 2 of them. So what times 7p squared would give you 14p cubed? And that is 2p. Now what times 7p squared would give you a negative 21p squared? And that is minus 3. And then again, you might want to go ahead and distribute just to check your work, but this is the factored form of 14p cubed minus 21p squared. Okay, so take a look at this hot mess. So now let's look at the numbers 12, 6, and 15 and ask yourself what is the biggest number that can be factored out of 12, 6, and 15. Now 12 and 6, you could pull out a 6, but you can't pull a 6 out of 15. 6 doesn't go into 15 evenly. So really the number here is 3. That's the biggest factor that goes into all 3 of those. Alright, so now take a look at your x's. What's the most number of x's that I can pull out of any one of these? I can only pull out one of them because of this guy right here. Now take a look at your y's. This one has 2, this one has 3, this one has 2, so I can only pull out 2 of them. So this right here is our GCF. So now you want to ask yourself, what times 3xy squared would give you 12x to the 4th y squared? Okay, so I do this piece by piece. So what times 3 is 12? Well, that's 4, right? So what times x would give you x to the 4th? X to the 3rd power. Now I've already got y squared, so I don't need any more y squared, so I'm not going to put anything in there with that. Now I'm going to go to the next term. What times 3 would give you a negative 6? Negative 2. What times x would give you x squared? X. And what times y squared would give you y cubed? Y. Now I'm on to the next term. What times 3 would give you a positive 15? Plus 5. I don't need any more x's, and I don't need any more y's. So there we go. And we just factored out the GCF. Oh, by the way, that should be a T right there. Alright, so let's take a look at this problem. So between the numbers 2, 6, and 20, what's the biggest number we can factor out? It's going to be a 2. Look at your x's. What's the most, or I guess I should say the least number of x's that we have here? We have x squareds, because remember, I can't pull x to the fourth out of an x squared, so I can only pull out x squared. And then each one of these only has one y. So ask yourself, whoops, where'd it go? There we go. Ask yourself, what times 2 would give you 2? Okay, so I don't need any numbers there. You can put a 1 if you want, it won't hurt anything. What times x squared would give you x to the fourth? X squared. And I don't need any more y's, so I just have plain old x squared inside the parentheses. What times 2 would give you a negative 6? Minus 3. I need one more x there, and I don't need any more y's. What times 2 would give you negative 20? Negative 10. And I don't need any more x's, and I don't need any more y's. Now, once you get to this step right here, you need to ask yourself, is it possible that this that's inside the parentheses could be factored? Let's figure it out. Let's go back to yesterday's lesson. So I would take the leading coefficient times the constant, and I get negative 10. And I'm going to list all the factors of negative 10. So I've got 1 and negative 10, negative 1, positive 10, I've got 2 and negative 5, and I've got negative 2, positive 5. This one adds up to be negative 9, this one adds up to be positive 9, this one adds up to be negative 3, this one adds up to be positive 3. And so I know that it can be factored because this one adds up to be the middle term. So I can go ahead and factor what's inside this set of parentheses. This thing has to sit out front. And now this trinomial factors to be x plus 2, x minus 5. And now it is completely factored. Okay, so here's just a rule. It says, warning, when factoring a polynomial, always completely factor it. Okay, this is kind of an important page. So it says how to factor when the leading coefficient is negative. When the leading coefficient of a polynomial is negative, we first factor out the opposite of the GCF. So that means that you want to factor out a negative whatever. Whatever it is the GCF, you want it to be negative if your leading coefficient is negative. Alright, so take a look at this. So ask yourself, what do 5, 30, and negative 40 have in common? Well, we could factor out a 5. But because our GCF, or I'm sorry, our leading coefficient is negative, I want to factor out a negative 5. So I factored out a negative 5. How many x's can I factor out? Because of this thing right here, I can only factor out one x. So what times negative 5x would give you negative 5x cubed? X squared. What times negative 5x would give you a positive 30x squared? That is a negative 6x. Remember, because a negative times a negative is a positive. What times negative 5x would give you a negative 40x? And that is a plus 8. Now you want to ask yourself, is this thing factorable? So 1 times 8 is 8. Here are all my factors of 8. I've got 1 and 8, negative 1, negative 8, 2 and 4, negative 2, negative 4. Is there a pair that adds up to be negative 6? Yep, I see it right there. So this trinomial factors to be x minus 2, x minus 4, but don't forget this, it's got to sit out front. Now it's completely factored. Alright, so go ahead and read through this, and you might want to take some notes over it, but I'm going to show you what this means here in just a second. Alright, so whenever you factor by grouping, here's what I always do. I always tell people, make sure it's written in standard form first. So highest exponent written down to your lowest or your constant term. Then I tell people to underline the first two terms, underline the last two terms. When I underline the first two terms, I'm only looking at these two terms. That's it. I don't care what's after that. I'm just asking myself, what did 9 and 45 have in common? They have a 9 in common. What's the least number of x's? It's x squared. So I just factored out a 9x squared out of only these two terms. So what times 9x squared would give you 9x cubed? X. What times 9x squared would give you a positive 45x squared? Plus 5. Okay, here's a trick. If this right here is a minus sign, you put a minus right here. If that right there is a plus, you put a plus right there. So we have a minus, so now I ask myself, what do 4 and 20 have in common? They have a 4. What times negative 4 would give you negative 4x? X. What times negative 4 would give you negative 20? Plus 5. Now, if the thing, I should say binomial, if the binomial inside the parentheses does not match, you cannot go on to the next step, so don't even try. But see how they both have an x plus 5? We can actually factor out that x plus 5, and what we're left with is 9x squared minus 4. But do you remember from yesterday, we were factoring a difference of squares. Notice how that's a difference of squares. So I've got x plus 5, and do you remember how a difference of squares factors? We've got 3x that goes there and there. We've got a 2 that goes there and there, and one's a plus, one's a minus. Now, this thing is completely factored. Alright, so that's it for this lesson. If you have any questions, let me know.